My project was done in Google Cloud using Python. Started with analyzing the data, looking at what features were, so what information was going to be my feature variables, and determining my feature variables to be T, AP, RH, V, as we're trying to predict PE. This is a regression problem, so I decided to start with a linear model to establish a baseline. So I started with importing with a quick data cleanup to see if there was any missing values. There were no missing values in the data provided. So to create the linear regression, I started with importing my libraries, splitting the data into X and Y. So X being ATV, AP, and RH, and my Y being PE, as we can see here. Then splitting the data into training and testing sets, creating the linear regression model, training the model, and making predictions. To evaluate the model, I went with the following metrics: MSE, MAE, MAPE, RMSE, and R square. We can see here the results of our linear regression model, which performed relatively well. But I wanted to compare this with a random forest. So I created a random forest regression model. Next, started again with importing the libraries that I needed, splitting my data into X and Y, splitting my data into train and test sets, and creating a random forest regression model, training my model, and using the same metrics to have a clear comparison between the linear regression and the random forest regression model. So you can see our random forest performed better. As a quick refresher, here's the information in our regression model and the results provided versus our random forest regression model and the metrics. We can clearly see that the random forest regression model performed better. So we'll continue with the random forest regression as my chosen model. Then tweak some of the hyperparameters, and the hyperparameter that I wanted to tweak was the number of trees. Given that the number of features is only 4, I decided against removing some of those features and just tweaking the number of trees to see if it would perform better. Given the results provided, it's clearly seen that the 100 trees was the best way to go. Also taking into consideration the computational power required by the 1,000 trees, and the results weren't really that different. So I went again with that 100 trees as my hyperparameter of choice. And so I wanted to make sure that the results of the model could be replicated. So the next thing I did was validation using k-fold validations. And again, I imported the libraries that I needed to do a k-fold validation. The number of k-folds were 5. And then I continued with using the same metrics. So we got MSE, MAE, MAPE, RMSE, and R square again. And for each of the folds, Dan decided to split the data into training and test folds. For each of the folds, created a random forest regression model, trained the model, evaluated the model, and calculated the average across all folds once they have completed. The results are here. This is the output of my model. We can see the original random forest regression model results versus the random forest regression with k-fold validation results. So you can see this is a model that can that our original model can be was pretty good and can be replicated. So in conclusion, to calculate the PE, given the features and the amount of data provided, the use of a random forest regression model will provide a highly accurate prediction.